So let's take a look at this for this video, 921. The goal is to understand how to graph a hyperbola and how to write a rule for a hyperbola. So the first thing we need to know is what is a hyperbola. And I'll read you the book's definition and then I'll re-explain it with another kind of explanation on what the definition is. A hyperbola is the set of points in the plane, the difference of whose distances from two fixed points is constant. Okay, so again, let me rewrite that with a little bit different wording. So it's a set of points where the difference between the distances to two fixed points is constant. A set of points where the difference between the distance to two fixed points is constant. So the good news is the definition kind of fits the standard form. Now take a look at the picture. These are pictures of hyperbolas. The distances we're talking about are, here's the two foci in green. This is one distance to this point on the hyperbola. This is the other. If we subtract those two distances, we'll get the same number as if we picked a different point, went to the two foci, we'd get the same exact difference. No matter where we go. If we pick this point and we subtracted the two distances up to the focus, we get the same exact value every single time. So that is the definition of a hyperbola. It's similar to an ellipse. Ellipse was the sum of the distances was always constant. Hyperbola is the difference of the distances is always constant. There will be some interesting applications for hyperbolas, so pay close attention to that. But first, let's just understand some of the basics. There's still going to be a center. There's still going to be two focus points. And there's still going to be two vertices. So all those key characteristics you've been finding lately are going to continue to exist here. Hyperbolas. What's interesting about their rules, their standard form before we translate them and shift them, instead of adding, we subtract. So the rules are very similar to ellipses, but we're going to subtract y squared over a squared minus x squared over b squared. What happens is when y squared is first, so this is the equation, y squared over a squared, x squared over b squared. When we subtract with y first, we're going to have an upward and a downward facing hyperbola. And of course, when x is first, now we're going to have a left and a right facing hyperbola. So that's going to be the key thing that we have to pay attention to when we're trying to graph these hyperbolas. Now, let's take a look at the first graph then and how we're going to do this. The first graph is going to, the center is going to be 0, 0 because there's no shift. So just like we've been finding center elsewhere. The other couple of things that we'll have to graph are the vertices and the focus points, and then of course the curve. So here's how this is going to work. The vertices and the focus points are still going to be by counting and looking for what number squared equals 49. So in the first case, it's 7 squared. So that means from the center, I'm going to go 7 to the right and 7 to the left to find the vertices. And these are the vertices because x came first. Y is 15, but of course that means it's the square root of 15, which is about 3.8. So 3.8 up and down. I'm still going to graph that, even though it is not actually going to be a point on my graph. The reason I graph that is because we need to know how this curve looks. So the curve is definitely going to be at these two vertices. But the question is the curve going to be really skinny? Or is it going to be really wide? And the way we'll figure that out is by using those 4 points that we just graphed, using the 49, and the 15 that we found up there, and the 7 and the 3.8 that we see here. So how we find out how wide the graph is simply by sketching a box that goes through all 4 of those points. So this would typically be the box the ellipse would be contained in if I simply changed this to a plus. Then I would sketch the ellipse inside of this box. But the hyperbola is outside of this box. And the second thing I have to do is draw a line that goes from this corner all the way to this corner. And I'm going to extend it past those corners. These are my asymptotes. These are the asymptotes that describe how the hyperbola will react to the long term. So now I know how to sketch my graph and how wide it will be. And it's literally as simple as that. So we still sketch the 4 key things using these 2 pieces of information, the 7 and the 3.8. So again, we went up 3.8 here and out 7 there. And we sketched in the lines, and then we drew the hyperbolas. The last thing we have to find is the focus points. So this is the first set of notes. So hopefully you have your note sheet with you so you can start recording this. But the focus points are still C, but in this case now it's going to be A squared plus B squared. So it's kind of a flip from the ellipse. Now we're going to add the two squared items together. So in our case we're going to do 49 plus 15 equals C squared, and we get 64 equals C squared. Well, that means C is 8. So again, from the center, I'm going to go out 8 to find my focus points. Out 8 in both directions. Again, it's going to be on the more important axis, the major axis, so to speak, because it's going to be inside the hyperbola. So notice the points are inside the hyperbola, the focus points are. And that's the whole point. We'll talk about how they're important for applications, and you'll see why that's really important. Now what we're going to do now is add to your notes. So bear with me here, this video might be a little bit longer, but add to these to the notes. Now let's talk about a shift. So notice in this graph, so these are your note sheet. In this graph, notice it's upward facing. So right now you should already know that y comes first. And it's going to be over a squared. And it's going to be y minus h. I'm sorry, y minus k. It'll still be minus k. It'll describe the center. And then we'll subtract x minus h squared over b squared. Now, this is your standard form of the rule. Again, the good news is a lot of things stay the same. Your center is going to be h comma k. Your foci are going to be found by doing c squared equals a squared plus b squared. Vertices. How do we find the vertices? Well, we know they're going to be in the y direction because of the y coming first in the rule. Oh, I'm sorry, I forgot this part of the rule. It should equal 1. We know they're going to be in the y direction, so we're going to take our point hk and we're going to go up by a and down by a. So my vertices are at h comma k plus a and h comma k minus a. Up and down a. And then, of course, the box, add this to your notes, the box is going to be b wide because that's the value under the x, so that's the width of the box. A couple other things you can add to your sketch is that these are the asymptotes that describe the long-term behavior of this hyperbola. And last but not least, the foci. So remember, just like the vertices, now we're going to go h comma k plus c, and then h comma k minus c. So we're now going to go c in both directions. And c should be larger than a, making the foci inside of the curve. The next one is going to be fairly identical, the next set of notes. Now we have an horizontal facing graph. So we have a similar equation, similar vertices, but notice the graph simply is left and right instead of up and down. So the rule is almost going to be exactly the same, but it's going to have x first. So first we're going to start with x minus h squared over a squared minus y minus k squared over b squared equals 1. The center is still h comma k, that doesn't change. But now my vertices, notice they are a away from the center to the right and to the left. So that's a distance of a. So my vertices are going to have a shift vertically by doing, left and right by adding a to h. You're still at the level of k and subtracting a. Those are your two vertices. And your foci, again, it's the same rule. So a lot of things are staying the same. It's most important to decide which way it opens, and then you sketch from there. And then the foci will be h plus c and h minus c comma k. So the last thing I want you to add to your sketch is the box that should have been drawn into the sketch. The box that should be drawn, and the one other dimension is that this is a distance of b in both directions. And that's how we get the box. So it's very similar to setting it up for an ellipse. It's just where you end up putting the curve that's different. Now let's take a look at another example using the whole translation idea. So here we have an equation. The number one thing we need to notice is which one comes first so we know which way to open the graph. And we see y coming first, so we know this hyperbola will open up and down. We also need to find the distances. So 9 is actually 3 squared, and 7 is actually the square root of 7 squared. And the square root of 7 is about 2.64 squared. So now that tells me the dimensions of my box. I do need to find the center, though, before I can start the graph, and the center is at positive 3, comma negative 1. I almost switched the order. But the 3 is with the x, so that's why this is 3. So let's go to the center, 3, negative 1. Now let's start to draw our box. So 3 is underneath the y, so we're going to go up and down 3 to find the top and bottom. And in fact, those are my vertices. So maybe I'll label them with V's. My box will be 2.64 wide, so just over 2.5. And now I can start to sketch in, with dotted lines, the box that I can form. And then I can start to see the line that I should sketch that goes from one corner to the opposite, one corner to the opposite, and I can extend them to see what will happen to my hyperbola over time. Now I'm going to start to, find the focus points, graph them, and then draw the curve. So the focus points is always going to be c squared equals a squared plus b squared. So I'm simply going to add 9 plus 7. 9 plus 7, I get 16. That's c squared, so c is 4. So that means my foci are 4 away from my center, so I'm going to go down 4, and I'm going to go up 4. Those are my two foci. And last but not least, draw the curve. So it's going through the vertex. It's going to hug the asymptote over time and open up and down. So there's lots to think about here, but really it's very similar to ellipses. It's just about where to put the curve at the end. But otherwise, it's a lot building on ellipses. So now we're asked to write a rule for this. Well, if this is the graph, by the way, the red points are the foci, even though it doesn't tell you. It should have told you that. So that tells me I see a distance of 3. So that tells me that C is 3. The other things I can start to gather is that these are my vertices, and there's only a distance of 1. So that tells me my A value is 1. I also notice the graph opening left and right, so I know my X value comes first, and then underneath my x is my 1 squared, minus, because it's a hyperbola, y over b squared. I don't have b yet. Equals 1, of course. Now, I also noticed the center's at 0, 0, so I really didn't need all of this, but just to be clear, it's the center of 0, 0. My last step here is to find b, so very similar to ellipses, that's probably going to be your hardest point. We got to find b, and the way we're going to find that is by using our relationship c squared equals a squared plus b squared. We know c is 3, so 3 squared equals 1 squared plus b squared, because we knew a was 1. So we end up getting 9 equals 1 plus b, so b is 8. B squared, excuse me, is 8. So that tells me my b squared value is 8. It was not sketched in the picture, but again, I can use the clues to decipher what I need. So here is your final equation for this hyperbola, and you are finished. So the checkpoints are similar to these last two examples, where you have to graph one and write a rule for one. Pay close attention to the Google form that you're filling out. At the end, it will give you a hint on how to check your answers for the checkpoints before you even come into class. But submit your answers in the Google form so we can use them to help you further and clarify things that were unclear in the video. So good luck, and bring those questions into